I'm Chelsea, and here's Metalunar's demo. Metalunar is building a reliable, affordable interplanetary internet. You can think about it like internet meets GPS, but for deep space. Right now, we are rapidly expanding beyond Earth. We can see this through NASA's commercial lunar payload services, which will be given $2.6 billion over the next 10 years, or SpaceX's Starship, which has the potential to open a billion-dollar market once mass constraints are relieved from payloads. The only current solution we have right now for communications and positioning is NASA JPL's Iris radio. At a price tag of over $1 million and a lead time of over a year and no intention to profit, it's not a good solution. We aim to solve this problem by building and manufacturing space-rated interplanetary radios and offering ground station and lunar relay services by pay-per-usage access to our network. That'll generate recurring revenue as well. There are a lot of potential customers, including ground station services for low Earth orbit, which is an enormous $120 billion market, as well as research institutions, which are launching more and more nanosatellites and CubeSats over the past 10 years and are projected to launch an increasing amount over the next 5. We're also looking at agencies like NASA and ESA, which have both demonstrated market need by putting out a number of RFPs and RFIs asking for someone to build the interplanetary internet. The way it works is our ground stations on Earth connect to our relay satellites, and those are able to communicate with the user radio, which could be either in orbit or on the lunar surface. Our radio is space-rated, modular, affordable, and reliable. One of my favorite things about it is that it's optimized for data rate, not for current ground station constraints. That means we get to use the Ka band, which is significantly less congested and much faster than any previous deep space used bands. Here's a diagram of our radio configuration. It's a software-defined radio, meaning that all of the radio implementations are done over the software. It's also on a field programmable gate array, or FPGA, which is a radiation-hardened chip. There's a huge problem with radiation destroying components in space, but our radio will not have that problem. What we need to make it happen from Y Combinator is guidance in developing an executable plan, especially for something as ambitious as the lunar market, as well as seed funding to build our prototype and hire an RF engineer to do so. We'd also love advising on how to continue pitching to investors. Thank you.